Well, okay, I have 11:15 Pacific on my side, so I think we're going to go ahead and get started because we do only have 45 minutes for this session. So welcome everyone. Good morning, good afternoon, wherever you are joining us from. My name is Catherine Stankin, and I'm the Vice President of Policy at the Electrification Coalition. We are a bipartisan nonprofit group that's working to accelerate the adoption of EVs on a mass scale in order to reduce our dependency on oil in the transportation sector. And this will then improve our national security, our economic prosperity, and our global competitiveness. Oh, and I see our other speaker just joining us now, so that's great. We also just released a V2G policy recommendations report in June 2022. So I was thrilled to ask to be moderating this panel today, which is scaling vehicle to grid and why commercial fleets should be aware. So first of all, the housekeeping notes. This session is recorded and the recordings will be available within 24 hours on the replay section of Hopin, which is this platform here. And we'll be sending out the official recording within 2 weeks after the event to all attendees. Also, please use the chat on the right-hand side or the Q&A function because we'll make it a live discussion later. And then also please take the survey at the end of the session. That'll be on the right-hand side when we are finished today. So just to set the stage a bit before we transition to our first speaker, with EV adoption, light duty side and also the medium heavy duty side, we are only seeing about 1% adoption in some states. This is new vehicle sales. But for other states, we're already nearing the double digits. And so as we grow in adoption, now really is the time to be thinking about how we can take advantage of the benefits of electric vehicles in terms of providing that benefit back to the grid through bidirectional charging. And we've seen some pilots so far, but we definitely want to be talking today about how we can take the lessons learned from those pilot programs and scale up very quickly, and especially for some commercial fleets. So again, we have 45 minutes for today. And without further delay, I'll introduce our first speaker, who is Frank Brown. And he is the Senior Design Strategy Director at Ford. So Frank, please give us some of your remarks, and then we'll circle back to you.
Okay, great. Why don't I just do a little bit of an introduction? So I am part of Ford, a human-centered design leader within the Ford organization. We call D-Ford, which is a part of the design organization. We work on many different challenges and opportunities within the Ford enterprise. I've been at Ford about 6 years, and if you've been looking at Ford from the outside, we're accelerating our transition to electrification. I actually find it something I'm quite passionate about, and they're meaningful design challenges. As a designer and someone who leads design teams, we really seek to deeply understand the customers and identify what the best opportunities are for those customers. And we do that around the globe. I'm very proud to work with a lot of really talented designers. And we work on many things. One of those is people's relationship to energy and energy use. It shouldn't be surprising that we at Ford know a lot about our customers, right? But I think what's interesting in my role is we really seek to future those insights about the customers and put them into a future that includes electrification and automation, and understand what challenges are going to emerge, right? Because this type of underlying change in the technology of our mobility can disrupt people's mental models and expectations. We see that when we talk to non-EV drivers for today. And as designers, we help mediate that change, right? And so we believe, we firmly believe that helping people understand and make their way through that disruption is going to separate, the winners from kind of the losers and go forward, right? What have we seen in this space? I think one thing that comes to mind, we definitely can often see the benefit for customers before they can, right? We understand these technologies in a way that may not be clear to them today. Examples like that, I think, are, even before we got to EVs, like Pro Power on Board, which we added to Ford F-150, came directly from the observation of what people were doing out in the world, right? And so we would see people loading generators in the back of pickup trucks and going and doing work. And we realized that there was a better way to do that, and it would also provide additional benefits, right? So this is the type of work we're doing as a design team. We talk to a lot of owners, operators, and EV intenders, and we see a lot of different mindsets. We see people who are kind of dedicated to this, fearlessly independent. They're on a quest, right, to build and live this. We often see, the obvious, like the early adopters. We see people who are really in it for the potential savings, and they're drawn to the notion that an EV is lower cost. We've seen what I would call like energy pioneers, and like people who are truly interested in what an EV could do as a distributed energy resource. All of these, I think, are super interesting to us at Ford. I think there's a genuine interest in these types of B2G benefits, but they're not. We need to make them understandable for customers, and I think that's where we, as designers, come into the picture. There are several teams actively exploring this across Ford. We partner with them. We continue to partner with them. We have teams in Palo Alto, teams here in Detroit, and teams in London, all working on these challenges, these opportunities. I see it as like, I see this as like the end game for our electrification strategy is really unlocking that additional kind of power for people and changing people's relationship with energy overall.
Okay, well, I want to just pick up on what you said right there, that, unlocking this potential with V2G in the Ford F-150 Lightning. And how do you, I know that I'm ready to put my reservation in as well. I'm very excited for this, for the car to be out right now. And how do you see, potentially the F-150 Lightning working for rural communities specifically? We've got $7.5 billion coming from the federal level to build out charging along highways, and certainly some of that $7.5 billion is dedicated to set aside for rural and low-income communities. So I'm curious if you can just comment on that really briefly.
Yeah, I will say this. We obviously serve a lot of customers, a brand like Ford, and we know that we have a lot of customers doing a lot of jobs. Some of those jobs are quite extreme, right? They're in extreme conditions, or they involve extreme use cases. So we know we will continue to need a broad set of solutions to meet all of the customers out there. What I would say, the F-150 Lightning, we like to say it's a truck that does truck things, right? And it has not been compromised in any way because it's an EV. In fact, it's been enhanced, right? As you're saying, right? It's a massive mobile energy source. It's going to power productivity wherever it's going, and we've already seen that. And I think it's building on insights we've seen previously. I think the bidirectional power capabilities of that truck are really just the tip of the iceberg of like where this is going, right? And what stands out to me is, a lot of our truck customers might live in areas where the aging infrastructure is actually a challenge. I'm here in Michigan, and we had a storm here earlier in the week, and power went out for like 50,000 customers in the state, and so like I think it's just kind of the tip of the iceberg of like what the potential is here for these vehicles and for like an energy enabled future of these customers. So
yeah, that's a really great point then about kind of deferring the cost of aging infrastructure, providing power back to communities there, and I could see all sorts of applications there. So well, great. We're going to circle back to, there's already a question for you in the chat there, but you can work on your answer while we switch to our next speaker, which is, this is Sunil Chaya, and he's the Senior Technical Executive for EV Energy System Integration at EPRI. So Sunil, take it away with some of your thoughts on vehicle to grid and commercial fleets.
First of all, thank you for inviting me. Can you hear me okay? Does the sound come through okay? Because I could not hear I could hear you, Catherine, but I could not hear the previous speaker. I could not hear him at all on my machine, so something's going on. So I hope everybody else can hear me as well. Well, thank you again for inviting EPRI to this wonderful gathering here. At EPRI, we have been working on vehicle grid integration related work before it was called vehicle grid integration. Since 2007, when I joined. Prior to that, I spent a decade, 12 years actually, in the automotive industry, working at GM and then EV1 and so on programs. So I have seen this on both sides, and I can speak with some conviction and authority as to what's going on. So early years were focused on looking at all the different ways in which we can communicate within the vehicles and the grid, so that important information can be sent back and forth. The vehicles can decide for themselves, what is the best way to charge, and of late discharge as well. Standards, technology, valuation, markets. How the markets how are going to be what is required for the markets to evolve to integrate electric vehicles as a resource, so that the appropriate mechanisms can be established for value to transfer to the EV owners. So that was kind of the early work, and it's still a work in progress, but I think we have a lot of definitiveness on the standard side, especially on the DC side for vehicle to grid, vehicle to X, as it's called now. So we have focused quite a bit of work of late on a vehicle to X. And when you get to vehicle to X, meaning, it looks like the early use case that is getting a lot of prominence, and for the right reasons, is the resiliency aspect, as the gentleman from Ford was mentioning, Frank. So I think the reason for that is that it's a simpler thing to do, and the benefits are very tangible, direct, instant benefits. You plug in, and when there's an outage, you have electricity. In addition to that, you can use the vehicle battery very infrequently, because the outages thankfully are not very frequent, so infrequently, which means that there is no battery impacts from discharging the batteries frequently, etc. But at the same time, you don't have to have a dedicated energy storage system installed at the customer's home, which is a significant expense and a hassle for the customers to do. So vehicle can serve dual purpose, mobility and resiliency. So that's a great use case that is going to be there. So given that the wall box that implements, and Cliff can speak volumes to this because he's the expert in that space. But the wall box is on the wall, so I think that, and vehicles only require a software change. So you're going to find that pretty much every vehicle that's coming out in the next generation of vehicles, starting with Ford now, will have this capability built in. So it has got a very good prospects to be widely available. So that's number one. Number two, when we get to fleets, so the use case or the benefits to the retail customers, light duty, are fairly well known. When you get to fleets, things start to get a little bit I would say nuanced. And the reason why I say it is because the fleet operating profile, and when you may need the vehicle batteries for doing certain specific services, are not always overlapping. In other words, the vehicles only act as resources when they are plugged in and charging or available for charging. But if the vehicles are out delivering stuff, for example, then they are not available at the depot. So the segment that people have focused on quite extensively are school buses, because school bus operating profile happens to be you are ferrying around kids in the morning and in the afternoon when the school is in session, before and after school. So, it makes a lot of sense when the vehicles are gathered at a specific location. So you're seeing a lot of information coming out in that sense. The other aspect about fleets is that when you have infrastructure, a segment of the load, right, which is transportation, also dependent on electric system reliability. Not only are you disrupting the other business, but you are also disrupting the delivery business or any of the other thing if you don't have resilient infrastructure. So, for example, what happens to charging in the vehicles when there's no there's a disruption, power disruption? So there is going to be some way in which maybe fleet owners have an opportunity here to use resilience even in the fleet sense, where a certain part of the fleet is not operational, but it's just providing the resiliency to keep the critical systems up and running, the IT infrastructure, some of the other things, so that the warehouse does not have to completely shut down, etc. So there are certain specific things that could be done with fleets, but it's school buses, and then moving out beyond that, I think is what it's looking like right now. Thank you.
Okay, so quick follow-up question for you there. So you mentioned that on the light duty side that these are kind of well-known values. This has been studied a lot in pilots. Yeah. So I'm curious if you can comment on what is that value in terms of the scale? Are we talking about thousands, tens of thousands for the individual customer, but then also larger? And for fleets, same thing there. As you mentioned, electric school buses are a huge topic with V2G right now. Yes. And what is that? What is that looking like?
So that is a very important thing, because value basically drives everything. Customers not only need to see perceived value, but tangible value. So that is what I mentioned. If you are able to supplant or substitute for a stationary battery, with the vehicle's battery, there is you can see a direct correlation between them. So when you get to resiliency use case, it is a very tangible thing. But once you get beyond that, when you start looking at sending power back to the grid, the value becomes, the answer is always, it depends. It depends on many things. But first of all, so it all started with thinking that all these vehicles, and BMW were involved at the time. When Mr. Fiat was at BMW, there was a 100 BMW Mini pilot with PJM, and that is all great, and school buses will be doing that all day long, ancillary services, right? And so that's where it started. The issue with those types of markets is that the demand for these services is fixed. So as the supply goes up, guess what happens to the price that's available? It's kind of starting to taper down. So we see that asymptotically, that doesn't really pan out. As the scale goes up, value actually comes down, not lower. So where is the value? Value is in distribution. Now, distribution is a murky segment because no two distribution system segments are alike. So we have to really get careful about it. So where is the value then in the near term? Number one is renewable balancing. Number two is, looking at maximizing self-consumption and minimizing curtailment, right? So you get maximum value out of the renewables that you have installed, and get value from those segments. So that is where a lot of the discussion is focused on around V2X, and it is going to take a while before the market evolves. And there is a lot of absolutely, theoretical. We have done it, where you look at the deferred investments, as Frank was talking about. Absolutely, but the question is, no two are alike. So how do you quantify, and how do you create a market, and how do you do that? It is still happening. BMW iCharge Forward, I'll give another plug to BMW because they've been doing this for quite a bit. So it's a work in progress. Resource adequacy is another big area that is of discussion. ELRP, electric load reduction pilot that's going on. So it is an evolving field. It's going to continue to evolve. I think as the technology gets more mature, vehicles get out on scale, you're going to see more and more value pockets that are becoming available to the customers. But it's going to be not uniform. It is not going to be a huge chunk that we are looking at. A few $100s per vehicle per year, that sort of thing. That's what we're looking at. So value.
Okay. Yeah. And I know with the Charge Forward pilot, you mentioned that
yes.
the first phase of it and the second phase of it, but you raised a ton of great points there. And we're going to come back to some of the initial ways we can use the value from EVs there. And you mentioned the renewable balancing and then minimizing curtailment. I think that all those different use cases we need to circle back to. We're going to have a part 2 of this discussion, but before we go further, we're going to move to Cliff Fietzig, our third speaker for today, who is the Chief Technology Officer at InCharge Energy. So Cliff, tell us your thoughts there about vehicle to grid, commercial fleets. How fast is this coming? Technology changes.
Yes, thanks for having me, and hello everyone. Let me start at the beginning with where I'm coming from and working with Sunil and with the Ford guys for a very long time. I'm moving electrification forward. So spent my first 14 years at BMW since 2010, rolling out the Mini, the Active E, the i3, the i8. This is when we did also a lot of the pilots. You mentioned Charge Forward, which was a program, which was a V1G program where you were deferring charging and really trying to work along the requirements from PG&E. So yes, working through the release of the electric cars, and during that time also the standardization of all of the protocols. We started on the CCS. We had CHAdeMO and CCS. On the CHAdeMO side, we all have seen some V2G pilots because CHAdeMO was supporting V2G early on. Now we see the rollout in the CCS market, which is the predominant standard in North America. So working on all of these standards early on at BMW, then the last about 4.5 years, I was leading technology at Electrify America, which was really focusing on public charging. During that time, really moving the standards forward. So what we wrote 2012, 2013, with, for example, ISO 15118, plug and charge. You see that now coming with Ford has launched with Electrify America, as well as some other car companies, but really moving that forward. And for that public charging aspect, this is what I'm focusing now at InCharge is really focusing on the commercial side, using these standards which have been built and also driving them forward in order to enable new technologies for commercial customers. We want to talk about V2G, V2X today. You see what Ford is doing right now with the F-150 is really a V2X application supporting a site, supporting a house, supporting a home, supporting a local energy. The transition into supporting the grid still has to be done because we are seeing that the integration has not been done yet, that the communication protocols are still mostly proprietary because they're just not all there. So we have ISO 15118-20 rolled out as the V2X, V2G protocol, but unfortunately it's not going to be backwards compatible. So therefore, none of the current vehicles are going to be able to support ISO 15118-20, even if it brings more security and additional V2G features. So therefore, we see a strong direction in North America with SAE, the standards organization, working on 2847-2, which allows actually V2G implementations built on our current CCS protocols. So this allows updating a Ford vehicle, updating a school bus, updating a truck to do a V2X. This also brings in the charger part, as Sunil mentioned, right? Then we need a charger. So most of the OEMs are focusing on DC bidirectional, which allows on the vehicle side mostly software updates to enable that. You don't need significant hardware changes because all of the hardware change, which is moving DC energy to AC energy, feeding back in the grid, is in the wall box, is in the home charger. This is what Ford is doing with their charging station, which they're providing. This is what we are also doing at InCharge Energy with our bidirectional charger, where we are taking the integration into the grid, into the home, and doing that so that the car doesn't have to focus on that. And with this, we are moving forward now, having more and more charging options between 22 kilowatt up to 66 kilowatts available, and in parallel working closely with the OEMs on the standards and communication implementation. So this is really coming back to my person. We rolled out plug and charge. We rolled out all these technologies. This is now enabling commercial vehicles with new technology, which we need to really drive electric mobility.
Okay, thanks, Cliff. I was going to ask you as the follow-up questions here, how can the fleet operators be thinking about doing this now, or should they be thinking about doing this now if technology is changing a little bit? But it sounds like for some of this, it's a software update. For others of it is a hardware update. So can you comment on that? And then also, you've been involved in a lot of the pilots thus far that we've seen. So can you comment on maybe, what's your top takeaway from the pilots overall?
To the first part of the question, yes, you need to plan now. I have listened into another panel for fleet operators, which are building up their infrastructure right now. If you want to take the Ford Transit van, the electric one or whatever, if you really want to get them out, then you have new depots which are built right now and need to put infrastructure in. So the V2G application can support several different aspects. It can support that you don't have to do building upgrades because maybe you can use some of your vehicles to level the load, but also eventually to support the grid later on and tapping into that revenue stream. If you want to do that, on the vehicle side, for most of the vehicles, it's probably mainly software, even if it then goes into certification and only certain model years will support that. But it's a smaller change on the vehicle side. On the infrastructure side, it's a significant change. So if you decide to put a unidirectional charger in right now, you will not be able to convert that into a bidirectional charger. So if bidirectional use cases are for you a goal, then you need to plan that right now. Doesn't have to be all of your infrastructure, maybe just a couple, but you need to plan on that. On the pilot side, I want to follow up with what Sunil was saying, and you as well. We see most of the pilots around school buses, because school buses have a really scheduled behavior. So you know when they are parking, you know when they are out, and they are actually parking during the times when you can provide energy back to the grid. If you take one of Frank's vehicles, it's probably at a job site somewhere, and they need the energy there, and you are not being able to feed back into the grid at this time. They are parked overnight. That's where you can provide these kind of services. So school buses are supported, and you see that also in all of the regulations and the grant money. You ask about pilots here in Virginia, where I am. You have Dominion as the utility company. They are supporting electric school bus transformation, but you have to provide at least 60 kilowatt V2G. So this is kind of the trade-off where Dominion wants to see some support for the grid out of all of the efforts putting money in. You see the same in California with the HVIP programs, where you see significant funding coming in for school buses and other commercial vehicles. On the school bus side, also a V2G requirement. So all of this is coming right now. What I can say for the pilots, every pilot we have seen so far are proprietary pilots. So they have not been built on standards. They're trying to make it work just to show the grid impact. But now we're really working on productizing that and bringing it into the field.
Okay, great. Well, we're going to now move into our Q&A time. So you're all on camera already still. And so let's go to the first question here. I really like the one that Vanessa was posting in the chat here, because if I'm a fleet operator, sounds great. You know, Sunil talked about the value. I've got Frank's vehicle. I've got Cliff's charger. Let's do it. But I think that there's a couple steps in between there from theoretical to this is happening. So how do some of the energy markets need to change now to be able to take advantage of this? And this can be, it sounds complicated sometimes. If I'm a fleet operator, I've got to make sure my, Sunil, I think you mentioned that, you know, I've got to deliver my product. I can't compromise that mobility aspect just for this. I agreed to provide this service back to the grid. So what are the services out there that can help fleet operators do this? And really, how do we go from A to Z right now? So whoever wants to jump in and take some of that. Sunil, you're on mute.
I think Frank is also looking for the microphone right now.
Okay, so let me just say about for 30 seconds. Well, one is I think that as Cliff mentioned, you know, one is the interconnection process. You know, this when you go from level, you know, the unidirectional charger to bidirectional charger, you need to work through interconnection with the utility, and there is a queue, there is a line. You know, you need to get in line, make sure that you have all the administrative part worked out and the technical part. The good news is that the technology is ready. So that's number one. The second part is the market, you know, and markets are an evolving entity, market conditions, and it is also not uniform. So California, you've heard recently about Texas. So huge focus on resource adequacy, you know, do we have adequate margin in the system so that in the stress periods, you know, you don't have to shut down you allow, you know, the flexibility part. So what V2G allows is flexibility in the system. So it is highly valued at this point. And this is what PG&E's pilot that we are going to see in the near future is going to address. How to build flexibility with all the tools available. So that's kind of where it's going. In the near term, flexibility and resource adequacy are going to be driving the market participation for these vehicles.
Cliff or Frank, you want to add anything there?
Yeah, I just want to support what Sunil said. We see over the last years, even with already V1G applications and with battery storage on the grid, that the electricity market still needs to be built. So everything which is local, which is your transformer, which is your home, which is your job site, which is your building, this is kind of resolved, but really getting into the grid, you see the PG&E pilot, you see the Dominion pilot, you see some other utilities which are still trying to learn what is the right applications for that. And I think this is where the industry needs support, and also probably an alignment, because no car company, no charger company will be able to build different applications for 3,000 utilities in the US. So we really need to have a market which is similar, if not the same, from the East Coast to the West Coast.
Mm. So to follow up on that, so I know that the California Vehicle Grid Integration Working Group was very active 2019 to 2020. Their final report recognized 320 different use cases here, ranging from we're talking about renewable energy balancing, we're talking about wholesale market, other ancillary services. So it seems like, is there an order of priority there, and is that what you're talking about, that we need to really work through that prioritization and get the standards in place for this user, this case, this vehicle, and work our way down? What are your thoughts there?
Yes, I think you have the right direction there. What they did is they really looked into every single use case, and now I think we need the customer. Now we need the customer for me here is the utility, is the power grid. Now they need to come back and say, what kind of support do they need to balance renewables, to also balance load, to help with demand, all of that. But therefore, you have to have that customer feedback, because now this is an offer to the utility from the working group. The vehicles, the chargers, the infrastructure can provide that. And now they need to say what they need. And that also goes into the question you had before to Sunil about how much is that worth? Because they have to come back and say, okay, if I don't have to build whatever power plant or whatever it is, this is what I'm saving, and therefore this is what I want to give back to the end customer, to the vehicle owner, because it's a share of all of that.
Frank, I want to ask you then. I mean, if this is, there's a lot of stakeholder feedback needed here from the customer, from the fleet operator, and so is Ford maybe thinking about gathering some of that feedback? How are you thinking about that? And then when we're done with that, I'll ask you the question there about the F-250s and F-350s that's in the chat.
I mean, today we do. I mean, most of the commercial customers are, have really good telematics. A lot of the commercial customers, right? So they know their usage, and we're familiar with that type of behavior. When you were talking about like customer, I was thinking about what Cliff was saying around the marketplace with the utilities. That's not well understood today, right? And so we can size fleets and understand like what portion of that is available, but I don't know that we understand how big the demand is on the other side. It's not inside of a car company. We don't really know that today.
So,
and then I think just to add on to that, and I think this is what the VGI working group tried to do. EPRI was part of that, Ford was part of that, most of the OEMs were part of it, infrastructure, really bringing together the need. But I agree, and maybe EPRI is the gating element there. What is the value for the utility? I think that offer is on the table.
So I want to, Frank, have you speak to the question here about the electric, the F-250s, F-350s, and that incorporating that into the fleet, because sometimes we think, oh, bigger battery, bigger value, great. But I know that that's not necessarily always true when we're talking about the bidirectional charging here. So first, Frank, can you let us know, challenges about the F-250 and 350?
Yeah, I mean, we don't comment on forward plans, but I will say this, that we're continuing to make our investments where there's the most scale, and that pattern is going to continue until there's another business model or business value proposition, right? And so that has not emerged yet, so our investment continues to go where there's the most scale, which is light duty, right? So like where we've been.
Okay. So then so maybe to Sunil or Cliff, does it matter then if, is there a 1-to-1 correlation of bigger battery size and bigger value financially, monetarily, that a fleet operator would see or not? Or does it depend? I feel like your answer is going to be, it depends.
Sunil certainly is going to say it depends. No, but in general, I don't think so. It's more the use case and the time, because software like InControl, what we are using to manage the chargers, has to aggregate loads, because utilities are usually asking for a certain kilowatt over a certain time. So let's say some energy over 4 hours. Not one car is going to provide you these 4 hours which the utility needs. So you are going to aggregate multiple of these vehicles. And if you're aggregating multiple smaller batteries or multiple larger batteries, I think it's the total which counts here. It's not what is in the vehicle. And you can also wrap in on-site storage, whatever, to offset if cars are not there. So I think this is the total energy capacity you're giving back to the utility than what one specific car can provide.
And the second part I would also add is that the amount of power that is being sent back and forth, that is sometimes as important as the amount of energy that is being delivered. And that is constrained by the size of the charger, and the size of the charger is constrained by the circuit capacity of the building. So these things are all linked. So the thing is that when a fleet operator or a depot manager operations manager decides how much to invest, they want to have a good understanding of the value that's coming out. And if the value is uncertain, they're going to be on the conservative side and say, I'm going to give it a shot and see how it goes, but not go crazy over it because it's still uncertain. And again, no two locations are the same in terms of value, because this is going to devolve into a distribution system related challenge, and so there is a lot that we need to learn through these types of activities. And kudos to all of the stakeholders that are doing the work, sticking your necks out to get the technology out there in the field. So full credit to them.
Mm-hmm. Okay, let's get to Robert's question in the chat here, a little bit about the battery reliability, degradation, studies and testings around that. And Frank, the question for you is here really about how does this secondary use of the battery for grid reliability, robustness, installation services, et cetera, all that interact with the current warranty for the battery? And can you talk about that? And then I'll throw it to the other two to ask about some other studies that have been done to bust the myth about the battery degradation.
It's a great question, and I'll stay in my lane. I'm a designer, I'm not an engineer. It comes up when we talk with customers about these types of scenarios. It's one of the very first places that their imagination goes is what is what am I giving up, right? Like, how is this affecting the longevity of my EV or that sort of thing? So we know it's a concern of theirs. There are ways we can ideate around how to mitigate that concern. But that's what we're seeing, right? From a customer side.
Right, and adding on to that, the OEM has certain requirements, how long batteries have to last, what kind of degradation you can have over time. So not less loss than 20% over 8 years, 100,000 miles, stuff like this. So there are regulations out there, and no OEM is going to plan for swapping batteries during that life, because it just doesn't work for the business case. So therefore, if the OEM allows V2G, V2X applications, and maybe they limit how often you can do that, then this is well within their design of the battery and of the electric drivetrain. So therefore, I would always rely on the OEM. Their engineers, their durability testing showed that these features in the vehicle can be sustained for the lifetime of the car. And this is why they are allowing to do that. And looking back at early i3s, which we had out there with BMW, actually the batteries last much better than we expected back in 2012, 14.
So I wanted to underline this, the OEM involved. So first of all, OEMs are responsible for the warranty. So, they know the batteries the best. In fact, they are the only ones who know the batteries really well. And not the battery supplier and not the customer for sure, not the third parties. OEMs know the batteries the best because they put the systems together. So any kind of these types of schemes, where you have batteries involved for non-mobility applications would have to be absolutely governed by the software that is residing in the BMS, and that is validated, tested, and proven out, by the OEMs, so that durability requirements are all there. We have lucked out on lithium ion, where the cycle life turns that it's very it's fairly robust. It's a robust technology, so that is the bright side of it. But and in addition to that, we, as a part of a DOE sponsored project, we did a battery degradation study where we looked at exactly this question. So you talked about second life. Second life would be like after the batteries are out of the vehicle, but this is simultaneous mobility and grid services used while the battery is in service in the vehicle. We looked at that, and the batteries have quite a bit of capability, sufficient, you would call throughput, cycle life. In addition, when they are discharged infrequently and in a benign way, meaning you're not hammering the batteries like you would when you're driving, accelerating and braking, but it is a very moderate, So batteries are designed to have upwards of 200, 300 kilowatts out, and probably 50 to 100 kilowatts in. That's the capability they're designed to, and they are used for fast charging primarily, or while driving. But the charge-discharge patterns of these batteries, when they are in grid services type applications, are in the 10 or tens of kilowatts, so very, very small, so moderate. So heating, so that mitigates a lot of the impacts that we see. But regardless of all of that, so the good news is that batteries are robust. Number two, the charge-discharge cycles for grid services are much more benign than for driving. But number three, OEMs will always need to be in charge. The batteries will have to be designed for these applications, validated, and proven out to last the life of the vehicle. Then it happens. So right now we are going to see baby steps in that direction, which is the right approach. Keep the risk to a minimum, make sure maximize the value.
Okay, well, we're running out of time, but I want to ask one more question here by Anonymous, posted it in the chat. So they should take credit for it because it's a good question. But there's a lot of the V1G programs, kind of demand response programs that are out there. And can that be used as kind of a catalyst towards the bidirectional charging V2G programs? I think that's how the Charge Forward program started with PG&E and the BMW i3 as just demand response, and then saw value there. And so what are your thoughts there? And then after that question answer, then we'll go around and do closing thoughts.
I would say yes in general. It still depends a bit on the use case, because for the utility, it's kind of the same if you not take energy from the grid or you provide energy back to the grid. So therefore, every mechanism which had to be built for V1G is also applicable to V2G. Just V2G has a bit bigger impact than V1G, but the mechanism is exactly the same.
Sunil, any thoughts on that? V2G bigger impact than V1G?
Absolutely. So, when you jump, V1G can be done with the vehicles today, software change, information exchange, and you're good to go. So zero cost, maximum benefits. Then you get into V2G. Now you got some incremental costs on the hardware side, some delays, and now you got additional benefits. So it's again, everybody's going to have to weigh the costs and benefits. Like I said, resiliency is the near-term big ticket value item, and that's what's going to drive adoption.
Well, I'm going to turn to you all for your closing thoughts, but I feel like we're only just scratching the surface. There's so much more to talk about here with the use cases, with Frank, with the customer perspective that you were taking in mind here as you were developing the vehicle, with the policy recommendations. Cliff, you talked about standards very briefly in your 5 to 7 minutes there, and I know that's a huge area that needs to be further talked through, and what we need to create standardization here in the United States to really enable this. But I'm going to have you just all go around, what are some of your final closing thoughts and takeaways that you want the audience to have? Frank, we'll go with you first.
I would just say that I think the potential is quite great here, and I think there's definitely a lot of interest from our customers. And the things that stand out for me from this conversation is the lack of standards or the emerging standards that are maybe not there yet to enable that. So, but I definitely see the potential for this.
Sunil, let's go to you next. Closing thoughts, takeaways.
I would say standards and interoperability are the two major things that we see. Standards drive scale, and I think that standards do exist, but the adoption is going to be the key, and that's going to depend on business value, etc. So I think it's our job at EPRI to convince all the stakeholders to get on the bandwagon and make sure that we do it right. That's what we are.
Okay,
Yeah,
Cliff?
I can just follow up with Sunil. Standards and interoperability is for all electrification applications the most crucial point. And really, since we are talking about commercial, I would just urge that commercial fleet managers are engaging early to understand it, because they have worked with combustion engine vehicles in the past. They now have to do a transition, and therefore, let's get in a dialogue. Let's talk early, because that helps to build the right infrastructure for all the EVs to come.
Mm-hmm. Well, let's have a round of applause for our panelists today. Thank you all. Just as some quick closing thoughts here, or reminders, I guess. The session was recorded, so it'll be sent out to everybody within the next 2 weeks. And then also within 24 hours, it'll be available on this Hopin platform. And please take the survey that's on the right-hand side. It's next to the Q&A tab there. And that's it. We'll close it for today. Thanks, everyone.
Thank you so much.